on to the question types. So you've got problem-solving questions, which are really straightforward. These are just standard multiple-choice questions, really obvious and easy. You know how to do them, not the questions themselves, but sort of the technique here is really straightforward. The one thing to know about problem-solving questions is there always has to be an answer. And of course, just like, you know, I'm sure you guys have gotten plenty of these techniques and stuff before, but sometimes you want to work backwards, sometimes you can get it by estimating. One thing to note about these problem-solving questions is a lot of times, again, use all the information in the question, not just to weigh in on the content, but to weigh in on the technique you're going to use. It will speak to you. Let's say you get some very weird, wonky number that would require extensive calculation. And then let's say you look down at your 5 answers, and they're fairly spaced apart. You got like 1, 80, 200, 10,000 or something, right? Those are really, really far spaced apart, right? What that means is you're probably estimating, right? Does that make sense? So when the gaps between the answer choices are far, that's usually a hint that you're going to be estimating. And we'll get into a lot more of that. Like a lot of this will sort of, like I just want to get it on the table so you guys have heard it. Most of it will be cemented down when we actually go through questions. And we'll be like, oh yeah, look at that. That's something to keep in mind. Quantitative comparison. So this type of question asks you to compare quantity in column A with quantity in column B. So you're always going to have this. You're going to have some sort of information up here. You don't always have information, but you know sometimes there will be a little diagram. Sometimes there will be an equation, something like that. And then underneath it, you're going to have column A, and there's going to be something down here, and column B, and there's something down here. And then maybe the information is like x plus y equals 1, or something like that. The questions will look like this. There's only 4 answer choices here, right? Which is kind of nice, because there's 5 another one. So even if you had to completely take a guess, you have 25% chance. The answer A means column A is greater than column B. The answer B means column B is greater than column A. The answer C means they're equal. And the answer D means, means not enough information to solve precisely. Now, I love these questions because there's a very, very clear technique here. Again, I don't know why, whatever. There's a really obvious way you want to go about solving these. First off, notice you're just making comparisons, right? Which means most of the time with these questions, you don't need to solve for a number. And in fact, a lot of times, they'll set it up so that you could solve for numbers, but you don't want to. They'll leave that possibility in there, but it's going to take you a while, when you could do a comparison very, very quickly. So what this means is, usually when you're working these out, well, we'll get to the sort of the main technique here in a minute, but generally when you're working these out, you just need to figure out how they compare to each other. Find out some relationship between the two of them to get the answer. One other bit here is if you ever have to guess on one of these, this is off of my own intuition, nothing more. I give this no sort of certified guarantee or anything. If you ever have to guess on a quantitative comparison, guess D. The reason is I've noticed, just after looking at many, many problems, I think that there's a slightly higher percentage of D answers than there are of any of the other answers, just on quantitative comparison, the not enough information. The second reason is if you can't solve it, if you have to guess, that might be because it's not solvable, in which case the answer would be D, right? So just if you ever have to guess on these, I would guess D. I'm just going to say that. I don't have anything real solid to back that up with, other than I think the proportion's higher. And if you can't solve it, there's probably a high probability that it's not solvable, and that's why you couldn't solve it. Does that make sense? So go D. Okay. Now, so these quantitative comparison, so again, the problem-solving questions are really straightforward. You guys know how to do them. I'm sure you've been doing these multiple choice questions forever. These ones are a little bit different. These are unique. The cool thing is there's a very, very clear, explicit strategy that you should use anytime you see one of these problems. So if the problem, so first off, there's 2 types of quantitative comparison questions. There's those that you know have an answer, and there's those that may or may not have an answer. And there's an easy way to distinguish these. If the problem only has numbers, there's no variables, there's nothing, there's just numbers, there has to be an answer, right? Because numbers have, I mean, they're quantitative, they're clear. There has to be an answer. You've already eliminated D. So if there's just numbers, never guess D, right? So I guess I should qualify that last statement. If there's not that many of these ones, that's why I say always guess D, but if they're numbers, it could only be A, B, or C. So you've already eliminated one answer choice at the very least. Second, it tells you very clearly, and you'll see why in a second, once you get an answer, that's the only answer, and you can go ahead and answer the problem. And you'll see what I mean in a second. So once you find an answer, you know you have the answer, and you can answer the problem. So if you find A is greater than B, cool, A is greater than B, A, you're done. If there's only numbers. Okay, now if they have variables, D is not only a possible answer, but it's also a likely answer. So your approach, so again, notice there's two types of quantitative comparison questions. The minority being these ones that definitely have an answer, they only have numbers. You're just looking for A, B, or C, pretty straightforward. The other one, this is the one that I think screws people up, and if it has variables, shapes, whatever in there, and you might not know. Your strategy should always be, you should look at the problem and say, I'm going to try and prove that D is true. That's your strategy. Every single time. I'm going to try and prove that D is the right answer here. Now, in order to do that, what you need to do is find, so usually you'll get, so basically what you need to do is find that two of these would be true. So, for example, let's say we take this one, the one I told you was sort of a trick question, where it says x squared equals 4, and I said x and 2, right? Well, now, if we know that x equals 2 or negative 2, both of those values, what you want to do is you try and confirm D by trying to find more than one of these. So I say, okay, what if x equals 2? If x equals 2, then the answer is C, right? And I say, okay, but what if x equals negative 2? Well, if x equals negative 2, then this is going to be less than that, so the answer would be B. I just got two answers. The answer is D. So it's not like there's not enough information to get a solution, it's that there's not enough information to get a unique solution. Does that make sense? And so the strategy here is really, really straightforward. Just try and prove this. Every time, try and prove it. Now, clearly, you're probably, I mean, I think that begs the question, at least if you guys are paying attention and thinking about this, is, well, how do I know if I've got them all, right? I mean, that's sort of, I think that's the main problem with this is, what if you keep getting A? You keep plugging in numbers, and every single time A is greater, A is greater, A is greater, right? But maybe there's some number out there that you haven't picked that would actually make B greater, right? How can you be confident in answering A instead of D, right? You guys see the problem that I'm sort of driving at here? That's cool. We've got a couple of easy solutions. So first off, we're going to go over the 4 types of numbers that you want to plug in, and that's basically exhaustive. For the most part, for 98% of questions, it's an exhaustive set, meaning you will have tested all the possibilities. So we're going to go over that in just one second. Using those 4 sets and looking at the 4 types of numbers, the 4 categories, plugging them all in, you can have a lot of confidence that if the answer is consistently A, the answer is probably A. Right? Does that make sense? So every number you plug in, you keep getting A. However, if that happens, first off, if you can't get any further, mark A. Right? If you keep getting it, mark A. But what you want to do is take a step back if you keep getting A. So you get A. Here's a great example. So we haven't gotten into some of this stuff, but so let's say units. So this is another one. So units, digit. So units, digit's the one in the 1 column, right? You guys know what the units digit is? 51 if you want, right? Units digit, so this is the same units digit of 5 to the 72nd power, of 6 to the 83rd power, something like that. This is the way the question was structured. So you look at it and you're like, oh yeah, I have no idea. What is 5 to the 72? Obviously you can't calculate that, right? So here you would start looking for a pattern, right? So obviously they're sort of like, this isn't the best example of this, but it illustrates what I want to show here. So let's say I say, well, I don't know what 683 is, but I can start building up and just sort of looking at what's happening. Clearly, I have to find some pattern. They don't actually expect me to calculate that. So I go, okay, well, what's 6 times 6, right? Oh, it's 36. That's nice, right? And I say, okay, so 6, and I say, what's 5 times 5? And I go, oh, it's 25. Okay, that's great. In this case, A would be greater than B, right? And then I do it again. I say, well, what if I do it again? So again, you get 36, and then 18, and 21, 216. Do it again, 5, you get 125. Oh, again, A is greater than B. And without going through too much of this, you keep going and you do this, 3 or 4 powers, and you keep being like, wow, it's always greater than B. And then you look and you say, well, this one is always 6, right? And this one is always 5. Now, let's say you couldn't get any further. At this point, I would answer A, because it looks like a pattern, right? But the best thing to do and have a whole lot of confidence in your answer is take a step back. You don't want to take more than like 15 seconds, 20 seconds to do this. So you don't want to waste a whole lot of time. You probably already have the answer, but this way you'll know for sure. Take a step back and try and figure out why. What's causing that? Sort of what's the underlying cause of that? And here you might notice that because 5 times 5 squared is 25, you now have a 5 in the units digit right here. So when I multiply by 5 again, I'm always going to get a 5 in the units digit, no matter what I do, because 5 times 5 always has a 5, and then that's the first, right? Does that make sense? Same thing with 6 times 6. So you'd say, like, oh, clearly there's a pattern there. Now I can have utmost confidence that the answer is definitely A. That's what I mean about sort of take a step back and try and decipher why. Why is it doing that, right? What's causing that pattern that you keep seeing? If after, thinking about for 5, 10 seconds, whatever, 15 seconds, you don't come up with anything, that's fine, just go with A. But I always think it's nice to try and step back and understand what's causing whatever you're seeing. And then you can have a lot of faith in your answer, and you should be good to go. Does that make sense? Okay, the other thing to look for, one other thing you can look for is, let's say you keep getting A. A is greater, A is greater, A is greater, right? Now, let's say a good example would be, like, let's say x squared versus x, and it tells you x is greater than 1. So x can't be anything less than 1, right? And so let's say, well, let's just start plugging in numbers. Well, I've got 2, and I've got 4, and I've got 3, and I've got 9, and I've got, 4, and I've got 16. And you'll notice in every case, A is greater, right? Now, I mean, there's not really, I guess, there's sort of a pattern here. I wouldn't really call it a pattern in the sense of that last one, though. It's not like, oh yeah, it's like always causing that. Instead, what you want to look for is convergence or divergence. Mainly, if this is bigger, is it getting bigger by more, or is it getting bigger by less? Right? And the reason is you can probably see in your close here, because this isn't necessarily the case that this would always be greater, but with this it is. If you see them diverging, you're good. If you see, on the other hand, if you see them coming towards each other, right, that means they're probably going to cross, in which case the answer would be D. Right? Does that make sense? So that's the two ways. You look for the cause of whatever's happening, and you look for convergence and divergence. Make sense?